Fortress Marine Anchors, stronger, faster, lighter, presents the 2014 Chesapeake Bay Anchor Holding Power Test. Here's marine expert and independent reviewer Chuck Hawley.
Well, good morning. It's day 3 of the Fortress Anchor Test in Solomons, Maryland. We're at our 4th location and we're somewhat through the sequence of anchors. So we're now testing our 5th one in the sequence. In this case, it's the Fortress FX37 with a 45-degree angle. We've just deployed the anchor and we'll see how she does. So our first test on day 4 was in the 4th location, and it was the Fortress FX37 with the set in the mud position. Let's take a look at the graph that we got. This is something we've seen before, which is a number of sharp spikes early on in the test. We don't actually believe that the anchor is pulling and releasing. We think this may be more due to the dynamic positioning system because it's really hard to figure this out, and almost all anchors do it. But then you see that the amplitude of the waveform slows down. You have a steady increase up to a maximum of about 1,800 pounds. Then you have a very sharp decline down to maybe 700 pounds, and then the Fortress continues to move up all the way up to maybe a high of 2,300 pounds at the end of the test. So this is perhaps the best pull we've had to date. And what's nice is that when the anchor did have a reduction in its tension, it still kept the boat from going on the beach. So really good performance. On the 4th test of the Mantis, we had relatively constant performance for 6 minutes at about 550 pounds and just a little bit of noise in the signal. At about the 7-minute mark, it dropped down as if it had broken free, remained dragging on the bottom for about a minute, and then went right back up to about 550 pounds. So the 4th test of the CQR was pretty darn good. Went up to about a 550-pound tension and stayed there with minor fluctuations for 6 minutes. Then, and we don't have a good reason for this, but around 6 to 7 minutes, many of the anchors changed their performance. And in this case, the CQR went down to 0 and then continued to oscillate between 0 and about 500 pounds until the conclusion of the test. One of the things we're discovering on the 3rd day of this test is our 4th location, our so-called delta location, seems to be pretty good for most of these anchors. We just tested the FX37 with the 32-degree angle, and we got very good performance, an average of around 900 pounds, a peak of close to 1,400 pounds, and one very short disruption, and the anchor immediately reset. When the anchor came up, it was full of mud and a few shells. And interestingly, it's one of the few anchors that's shown us shells, meaning that we think that it has to really penetrate deep through the mud before it gets to a layer of shells. The Lumar Delta also had a very good 4th test. It showed steadily increasing tension up to about the 700 or 800 pound range and held that until 6.5 minutes. At 6.5 minutes, it broke free and went down to very low tensions for the rest of the test. Again, we have to point out that there's something about 6.5 minutes into this test. Anchors seem to change what they're doing. Sometimes they get much better, sometimes they go to 0. So this is the 4th test of the rock nub, and it's really interesting to take a look at this graph. If you'll notice, we start out at minimum tension and hit a little bump at 300 pounds about a minute into this test. Now at that point the anchor has been pulled about 8 to 10 feet. And then there's a little bit of noise, and then it goes down to an extremely steady 130 pounds all the way to the end of the test. Now 130 pounds is actually more than we would imagine, or more than some of the anchors do when they're just dragging on the bottom. So what we hypothesize is that the rockna is probably on its side, and the roll bar on the back doesn't have enough to grab onto to right it, and it's just dragging very gently on its side, cutting a shallow furrow in the mud.
Well, with the plow anchors, we're finding a pattern that at about 6.5 minutes, I mean, we have really great holding pattern here and good tension. It was up as high as about 950. And then right for whatever reason, at 6.5 minutes, the plows are taking a dive. And they just never seem to recover. They never seem to come come back up. It's just something we've been seeing no matter where we are in location around here.
In the fourth test of the Manson Supreme, we had a steady increase in tension for about 5 minutes. Let's take a look at the graph. You'll notice we have our normal oscillations and then a more or less linear increase in tension. Now this area up here is about 800 pounds of tension, and it lasts for about a minute. And then you can see the tension drops precipitously, and then the anchor never resets for the rest of the test. This point corresponds to a scope of about 6 to 1, and we don't think there's anything particularly special about 6 to 1, but I simply point out again that at about 6.5 minutes into the test, we have a change in the properties of the anchor. The other thing is when the anchor actually came to the surface, it had a big ball of mud between the shank and its roll bar. Most of the other anchors in this location have come up absolutely clean. That's the most we have seen. Wow. So thankfully, we're at the end of our fourth series of tests in our Delta location. The last anchor to be tested is the Spade. And the Spade has previously shown consistent performance, although not a lot of ultimate holding power. That was exactly what we observed this time. The Spade went up to an average of about 500 pounds, had one dip down to 300, and finished strongly. So, not a high amount of holding power, but consistency. At about 11 o'clock on the third day, we completed all of our assigned tests. We tested each of the 12 configurations or anchors in each of 4 different places. We got some great data. We decided to change things up a little bit for the rest of the day. One of the things that Fortress has recommended for people who anchor in soft bottoms is to preset the anchor at about a 2 to 1 scope. Now the reason for doing this is that steep scope allows the shank to be pulled up and the flukes to drop down so that you engage the bottom quickly. So using the Rachel Carson, we paid out about 75 feet of line, and we just pulled in gently about 15 feet of line to pull in that flukes of the anchor. Then we paid out the line and went through a normal test. Well, during that test, we went way above 2,000 pounds of holding power using the Fortress FX37 with a 45-degree setting. We knew it was going to be tough to weigh that anchor, so we backed down on it and started pulling up, and at one point the boat surged a little bit and we broke the cable. This is a cable that breaks probably at 8,000 pounds under perfect conditions, but it was around a tight radius, and that always reduces the strength. So when the cable let go, the test was over. We have an additional challenge though, is that we lost the Fortress FX37 and we lost our 20 feet of high test chain. So we'll have to replace those before we continue testing today. Okay, so we've broken the cable and we've replaced it. So now we're going for the third afternoon and doing some slightly different tests. First thing what we're doing is we're setting the anchors at about 2 to 1 scope just to see if by holding their shanks up and giving them a couple of feet of penetration, we get better results. This is one of the things that Fortress recommends so that it keeps the flukes going down and the shank being pulled up. We'll see if it's effective for both Fortress and for the other anchors. We're now on location Echo, our 5th location, and we've just pulled the Lumar Claw. Had a very consistent performance. I know you've heard me say this before, but in this case, rose up to a tension of about 350 pounds, and then with very minor variations went through the entire 10 minutes between 300 and 400 pounds. So, not a lot of holding power, but it didn't break out. This is the 5th test of the Manson Boss anchor. Now we're in the new location where we've only done the Lumar Claw anchor and the Manson Boss, so we're not actually sure if this is a better or worse area, but let's take a look at the results. In the case of the Boss, we had a number of cyclical loads and releases between about 180 and 420 pounds. At about the 3-minute mark, we went into a steady drag all the way to the finish. So it's our perception that some of these anchors have an unstable attitude in the mud. They kind of fall over on their side. And because of the sloppy, loose texture of the mud, they're not able to roll upright, and they simply stay on their side the entire way. This is a supposition, it's a theory. We don't have any data to suggest that that's the case other than looking at this tension graph. But I think that you'll find that many of the anchors just hold at about 130 pounds for minutes at a time. That's what's happening. In location echo, the Ultra had one of its best performances yet. The tension went up to a total of about 1,200 pounds and peaked there for a while, then dropped down to about 540 pounds for a full minute, and then finally it gave up the ghost. We expected to find the anchor caked with mud when we came to the surface, but as it turns out, the Ultra is so slippery that the mud really doesn't stick to it. So although it had mud with it, it fell off before we could actually take a look at it. The Danforth 35 high tensile held linearly up to about 780 pounds over 5 minutes, and it looked like it would have gone higher, but it didn't. It dropped out, went down to zero, and never reset except for a couple of minor blips. We expected the anchor to come up packed with shells and mud and all sorts of debris, but in fact it came up fairly cleanly, so we're not entirely sure what happened. Well, at the end of the third day of testing, Fortress's anchor test in Solomons, Maryland, we had a very productive day, but we also had some setbacks. On the productive side was that we completed 4 tests of each of the 12 anchors or anchor configurations, so we have some very good data that we can dig into. We also tried to change our protocol a little bit and ended up setting the Fortress FX37 in the 45-degree angle configuration so deeply that we ended up breaking this piece of 5/16 7x19 wire. Now, when this wire is new, it breaks at 9,000 pounds. We didn't put nearly that much tension on it, but we did run it over a fairly small radius, and the anchor was embedded deeply in the mud, and we broke the wire. So, it's a good indication that you got to be on your toes when you're doing things with highly tensioned wires. We got a lot done today, and we're going to be analyzing the data overnight and figuring out if there are any last configurations that we want to test on the 4th day. For now, that's all from Solomons, Maryland.